Good evening, Bearcats. This is Unit 6 review, and we're going to go ahead and get started with number 1. The first section we're going to do is we're going to simplify or perform the operation that is presented in the problem. So we're going to start with 1a, and that problem is x squared minus 49 all over 7 minus x. The first thing I would do is I would rewrite my denominator in standard form. So I would have x squared minus 49, and then in the denominator I would move the x to the front, making it negative x plus 7. I would now factor everything I can. At the top I can factor that's a difference of squares into x plus 7 and x minus 7. And in the denominator I'm going to factor out the negative 1. I'm going to make a negative 1 on the outside, and that's going to be x minus 7. That allows for a cancellation. So I'm going to go ahead and make that cancellation. If we were graphing, that would be 7 would be where the x value of 7 would be where the hole in the graph would be. And right now we have x plus 7 divided by negative 1, so that's just a negative and then x plus 7. We do have a restriction that we want to list. Our restriction would be x cannot equal 7, and that would be our final answer. Just so you know, I want you to continue this video, and there's some special instructions at the end, a special problem I have for you, plus some instructions about what else you want to review to be prepared tomorrow for the test. Alright, we're going to go to 1b. That problem is x squared minus 16 and x minus 4. Again, we're factoring everything that we can, so the difference of squares at the top, x plus 4, x minus 4. And on the denominator we have x minus 4. Again, we have a cancellation. And again, if there were a hole in the graph, or we were graphing, there would be a hole in the graph where the x value was 4. Let's go to make our cancellation. Our final answer is x plus 4. And our restriction is x cannot equal 4. Alright, now we're going to go to C. I'm going to go start a new piece of paper. It's a little long. Alright, so for C, for C we have a division problem. Remember, when we have a division problem, we're going to end up multiplying by the reciprocal of the second term. So that's the first thing we're going to do here before we start to factor. So I'm going to rewrite my problem as x squared plus xy minus 2y squared over x cubed plus x squared y, and now I'm going to multiply by the reciprocal of that second term. So the x will move to the top, and the x squared plus the 3xy plus the 2y squared will move to the bottom. Now we're going to factor everything that we can, just like we have before. So I'm going to factor the numerator of the first term. That will be x and x. And then we need to multiply to negative 2y squared, but add to positive xy. So we're going to have a positive 2y and a negative y. Think about that. Positive 2 times negative 1y would make a negative 2y squared. And if we go in the middle, we have 2xy, and we have a negative xy, which gives us a positive xy. It's a little tricky factoring. If that's bothering you, you need to go ahead and take a separate look at that. In the denominator, we can factor out x squared, and we would have x plus y. That's just a GCF in the denominator. In the numerator at the top of the second term is just x, and in the denominator, so the denominator is going to be x, and then again we're dealing with y's and x's, so you're going to have a 2y and a y. Since we wanted to add up to 3, they're both going to be positive. And we factored everything we can now, so now we can make our cancellation. Alright, let's make our cancellations. We have x plus 2y and an x plus 2y that will cancel. We have this x that will cancel down here with the 2 x's, so this all of a sudden just becomes x to the first. Be really careful. There's really no other cancellations. Don't try to force one or make it up. You can't do that. The x minus y will not cancel with your x plus y. So let's go ahead and just write what we have left. We have x minus y at the top, and in the denominator we have x times x plus y. And notice we have x plus y twice, so we can write that with x plus y squared. And that would be our final answer. Alright, now we're going to, in part D, we're going to subtract, and we know when we add and subtract, we're going to have to find common denominators, which means there's a little more work involved. All right, so here we go. We're going to find a common denominator first by factoring this denominator. When we do, we get x and x. We're going to multiply to 14 and add to 5, so we have 7 and 2. We need the 5 to be positive, so a positive 7 and a negative 2. All right, now we can notice that our denominators both share x minus 2. But our common denominator will have to be both, I'm going to write it down here once, x plus 7 and x minus 2. Our second term over here needs the x plus 7. So I'm going to multiply on the denominator so that we have a common denominator, but that also means I need to multiply by x plus 7 at the top in the numerator. The other big thing that you need to be careful of when we're subtracting is that negative, or that subtraction sign goes with the 4, so when you distribute, you're distributing the negative. So at the top of the first term we have this 3x, and then I'm going to distribute negative 4 times x would be negative 4x, and negative 4 times 7 would be negative 28. Then we're just going to simplify our numerator, and when we do, we have 3x minus 4x, so we have a negative x, minus 28, all over x plus 7, x minus 2. Please do not FOIL that back together. Please do not multiply all that back together. We've already taken time to pull it apart. You do not need to put it back together. Just leave it all factored. Remember, when we're graphing, all those factors are helpful in finding your asymptotes anyway, so we really don't need to do that. You can leave it in this form. I'm just fine with that. I do want you to write your restrictions. Your x values could not be negative 7, nor could they be positive 2. If you want to factor out the negative in the top, you would have a negative on the outside and you would change it to x plus 28 in the parentheses. So if that's your preference, I'm okay with that as well. Again, your restrictions would be the same, negative 7 and 2. So either one of those would work. That's a preference there, but I'm fine leaving it just as it was. All right, let's go on to part E. This is our last simplifying one before we move on to another concept. And by the way, we just worked 5, or we're in the middle of working our 5th problem where we're simplifying and performing the operations, and there are actually 5 of these types of problems on your test. So I would say that you really want to practice these and any other that I gave you in class or on a video to practice extra as well. All right, problem E is 2x over 8x plus 4, and then we're going to add this time 6 over 4x plus 2. All right, again, it's adding or subtracting. We have to find a common denominator, and to know really what our common denominator is, we need to factor in the denominator what we can. So on this side, we can factor out a 4, and we would get 2x plus 1. And on this side, we could factor out a 2, and we would get 2x plus 1. So notice they both already contain 2x plus 1. This has a 4, and this has a 2. If I multiply this 2 by 2, it would become a 4, and my common denominator then would be 4 times 2x plus 1. But because I multiplied by 2 right here, I need to multiply by 2 at the top. So at the top, I would end up over here with 2x, nothing changed. Over here, I have 6 times 2, so plus 12. And actually, we're almost done. You could actually leave it like this, and I would probably be okay. I do want your restriction where x could not equal negative 1/2. But you could also factor out the 2 at the top and make it x plus 6. And I'll tell you the reason why we want to do that. You're going to see another cancellation, 2x plus 1. And you can reduce the 2 and the 4. So this becomes a 1 and this becomes a 2. So your final answer, preferably, would be x plus 6 over 2 times 2x plus 1. You also want to factor out, because sometimes your entire factor would cancel. Again, your restriction is x cannot equal negative 1/2. So this would be the Go Bearcat answer right here, and this would be acceptable. All right, let's move on to another concept. All right, this next problem, we're asking you to factor the expression, and it actually tells you in the problem by removing the common factor with the smaller exponent. So we actually give you a hint. But this is something that's a little tricky, and that if you have not practiced enough of these, you will have trouble with them. So make sure the ones that were assigned for classwork, go back and look those over. Make sure that you've done them all and checked your answers in the back of the book. There were several in classwork that you could do just as extra practice. Let's take a look at this. The common factor I see, or the common factor I see here is x squared minus 2. X squared minus 2. My denominators are negative 7 and negative 6. Negative 7 is smaller than negative 6. Think about a number line. Negative 7 is smaller. So we want to factor that out. I'm going to pull that to the outside, and we're going to have x squared minus 2 to the negative 7 power. And then I'm going to put a bracket. And it's a little hard to see. Matter of fact, sometimes if I put a bracket around these, it makes it a little easier to visually see what I'm looking at. So if I look up to this first bracket right here, and I look at multiplying so that I can equal this part right here, I already have the x squared minus 2 to the negative 7. I need the x squared, so I'm going to put the x squared here, because if I multiplied those together, I would get back to what I had originally. I'm going to go ahead and keep this subtraction sign right here. And again, I have x squared minus 2, but this is to the negative 6. I need to do something to this, so I'm going to go ahead and put my x squared minus 2. And here's where you have to think. I need this exponent added to this exponent to equal negative 6. So I need negative 7 plus something to equal negative 6. And that would just simply be a 1. So negative 7 plus 1. Remember, if you have the same bases, you add the exponents. So negative 7 and positive 1 give me negative 6. That's just to the first power, which means it will just remain as it is. So I'm going to go ahead and rewrite this one more time. You may can skip this step if you're really getting this. I'm going to put it just in parentheses, and we have x squared. I'm going to distribute through the negative, which is really important. So I have minus x squared, and I'll have minus a negative, so plus 2. Since that's 1, I don't have to worry about that. Then I have this cancellation, x squared and minus x squared. That's going to cancel. So now I have x squared minus 2 to the negative 7 power, really times 2. Now, we don't like negative exponents, so I'm going to take this entire term and I'm moving it to the denominator, which will change my exponent to a positive. Alright, so when I do that, I'll have 2 over x squared minus 2 to the positive 7. And that will be my final answer. Go Bearcats. Alright, this third problem, you will have one of these on your test as well, and the instructions are to simplify the difference quotient by rationalizing the numerator. We're even giving you the actual instructions here. We've rationalized denominators all year. That's where we clear out the denominators, often multiplying by a conjugate. We're going to do the same thing this time, but we're going to do that with the numerator, the top number. So we're going to do that in the numerator. So we're going to take this and we're going to multiply by its conjugate at the top. So the conjugate would be the square root of x minus 7 minus this, plus the square root of x. That would be the conjugate. And if I do that in the numerator, I will also do that in the denominator. So the square root of x minus 7 plus the square root of x. Alright, so when I multiply the tops together, remember they're conjugates, so the middle term always cancel. I only multiply the first times the first. When I multiply a square root times itself, the root goes away because it really becomes the square root squared. And I would just have x minus 7 left. And when I multiply the last times the last, I have a negative and a positive, so it's minus. The square root of x times the square root of x would just be x. In the denominator, I'm going to leave it for a minute. I'm just going to write the 7 out here by itself times the square root of x minus 7 plus the square root of x. At the top, you notice you have an x and a negative x that cancels. So you're left with negative 7. And you have a 7 in the denominator that would also cancel. So I can cancel this. Be really careful though, because of that negative, you're left with a negative 1 at the top. I just want to make sure that you catch that. So you have a negative 1 in the numerator, and in the denominator you simply have the x minus 7 plus the square root of x minus 7 plus the square root of x. And that would be your final answer. Again, go Bearcats. Okay, the next 4 problems are graphing problems. I'm just going to be sketching my graph on your test. You'll actually have a grid, which will make it a little easier for you to graph. The first one, you're always going to, if you look at the video for 2.6, there's a really good list of step-by-step how to graph these. I've mentioned that several times. There's also 3 problems given to you on that video that you really need to work through. I think that will really help you. So you really should be watching that again. Plus there's 2 application problems on there that if you don't work through them, then you may not get the application problem on the test. So you really want to make sure you've done that. Alright, so the first thing I'm going to do, there is no factoring to be done, which would be my first step, but I don't have standard form here. So I'm going to go ahead and rewrite this in standard form. So that would be 2 over x plus 3. The next thing I'm going to do is look at x-intercepts. We know that this whole equation is equal to y, and when we want an x-intercept, that means we want the value of y to be 0. So an x-intercept, remember, is when the y value is 0. Alright, for a fraction to be 0, the numerator would have to be 0. Well, in this particular rational expression, there's no way for that numerator to become 0. So in this case, we do not have any x-intercepts. So I'm going to write the word none. And that probably means that the x-axis is an asymptote. So that's just some kind of little bit of math intuition that you should be developing now. All right, the y-intercept, though, is when our x value is 0. So if I go back to my equation and I put a 0 in for the x value, I would have 2 over 3, or 2/3. And that would be my y-intercept. So I'm going to go over here to my graph, and I'm going to just put a point on the y-axis at approximately 2/3. And that would give me a point for my graph in a minute. The next thing I'm going to do is I'm going to work on vertical asymptotes. We know by now, hopefully, that vertical asymptotes are the same as your domain restriction. The restriction of this graph would be -3. So let's go ahead to our domain, and we would say that x could not be -3. It can't be -3 because it would create a 0 in the denominator, which would be undefined. And because that value is undefined, it creates a vertical asymptote. So our vertical asymptote is x does equal -3. I'm going to go over here to the right, and with a little squiggly line, I'm going to draw in my vertical asymptote. Asymptotes are really straight lines. I'm squiggling it just to distinguish the difference on this particular video. So here's my vertical asymptote, so you know it's not the axis. Alright, so we've got a point on our graph, and we've got an asymptote, and we know our graph will approach that in a few minutes. Our horizontal asymptote has to follow the rules of degrees. So we're going to compare the degree of the numerator with the degree of the denominator. The degree of the numerator in this particular case is 0. There is no x value at the top, and at the bottom we have an x to the first power, so our degree is 1. Since the degree in the numerator is smaller at the top, since our degree is smaller at the top, then we have y equals 0 as our horizontal asymptote. Y equals 0. Okay, if the degree in the numerator was larger, we would not have a horizontal asymptote and probably have a slant asymptote for this test if that degree was larger by 1. And if the degrees are the same, of course, then we must compare the coefficients in front of those x values. All right, so since it's 0, that would make it the x-axis, which we anticipated earlier because we didn't have any x-intercepts. Okay, finally, to go ahead and finish graphing, I'm going to create a little t-table of values. Listen one more time about your t-table. It's your choice. You get to pick. I want you to pick, though, values to the right and left of your vertical asymptote. Since my vertical asymptote's at -3, okay, I'm going to pick like -2 or -1. So I'm going to pick -1 first. I'm going to plug -1 into my original equation. You can plug it into either form. So if I plug a -1 in here, I have a -1 and a 3, that's a 2, and 2 over 2 would give me a value of 1. So I have an ordered pair on my graph at -1, 1. Then I'm going to go ahead and pick -2. If I plug -2 in, I get 2 over 1, which would be 2. And at -2, I'm at 2. Alright, so I've got 3 good points over here. I'm going to approach my asymptotes and draw in part of my graph. Now I need to see, though, what's happening on the left side of my vertical asymptote. Since that was -3, I'm going to plug in -4. You understand now I'm plugging it in for this x. When I do, I'm going to get an output of -2. So at -4, I'm going to be at -2. And at -5, I'm going to be at -1. You substitute that back in, and at -5, I'm going to be at -1. Again, I'm going to approach the asymptotes and go through those 2 points, and my graph would look something like that. All right, let's move on. All right. Now, the very first thing we want to do in this particular problem when we're graphing, and I'm going to go ahead and set my graph up over here, is we want to factor everything we can. So let's factor the numerator, and that's the difference of squares, so x plus 3, x minus 3. And of course the denominator, we're going to factor as well. We have x and x. We need to add to 4, but multiply to 4, but add to negative 5. I believe that'll be a negative 1 and a negative 4. We do not have any cancellations in the numerator and denominator, so we do not have any holes in our graph. So that's kind of a good thing to know. So let's go over here and take a look at the x-intercepts. The x-intercepts we talked about earlier are the values that make the numerator 0, because the numerator being 0 would create the entire fraction to be 0. So in this case, our numerator would be 0 if we had a negative 3 or a positive 3. So we have two x-intercepts, one at positive 3 and one at negative 3. So let's go ahead and mark those. So this is at negative 3 and this will be at positive 3, and those are two x-intercepts. Let's look at our y-intercepts. Our y-intercepts are when we plug in 0 for all our x values. So we'd have a 0 here, a 0 here, a 0 here. Notice I'm going back and forth between these two forms, and you can do that, whichever is easier for you to plug into. When I do all of that, I would end up with negative 9 over 4. And that would be my y-intercept. Negative 9 over 4 would be negative 2 point something, so a little bit more than negative 2, or a little bit less than negative 2. So we go down here, negative 2 point something, approximate where our value would be on the y-axis. All right, so now we have 3 points of our graph. Let's go on and check out our vertical asymptotes. Our vertical asymptotes are the same as our domain restrictions. So I'm going to go down here and look at that at the same time. Our domain restrictions would be 1 and 4. So we know that x cannot equal 1 or 4. We should also then know that x does equal 1 and 4 for our vertical asymptotes. So at 1, I'm going to draw a vertical asymptote. And over here at 4, I'm going to draw a vertical asymptote. So all of a sudden, my graph now is going to take on 3 different sections. You have the section to the right of 4, you have the section between 1 and 4, and you have the section to the left of 1. So you have 3 different sections. Let's also see if we have any horizontal asymptotes. Horizontal asymptotes, that's where we're comparing the degree of the numerator to the degree of the denominator. The degree of the numerator this time is 2, the denominator is 2. They are the same. If the degree is same, you must look in front of the x value. In this case, there's a 1 here, understood 1, and this would be an understood 1. So 1 over 1 would just simply be 1. So y equals 1 is our horizontal asymptote. If there was a 2 in front of the x up here, then it would be 2 over 1 and it would be 2. So just so you kind of explain that a little bit more. So I'm going to put a horizontal asymptote at positive 1. So now we have 3 parts of our graph. We're going to have 3 sections of graph. You're going to use a t-table to determine what happens to the graph in these different sections. I have 2 points on the left side of the graph, which is probably enough to go ahead and graph toward the asymptotes. So I'm going to go ahead and graph through these points and move toward the asymptotes. All right, so that part of the graph would look something, and do a very good job in there. That part of the graph would look something like that. Now, in the middle is always the trickiest part, and you need the most amount of points to figure out what's happening there. So let's go ahead and start our little t-table, x and y values. Again, I'm substituting back into these equations. You can substitute into either form. Sometimes it's easier just to plug the x values into all of these x values and simplify it. Whatever works best for you. If you're having trouble with that part, you need to probably talk to me. Alright, so I'm going to go ahead and figure out, since this was at 1, I'm going to figure out what happened at 2, which would be, we already know what happened at 3. So let's see what happens at 2. When I plug 2 in here, I get 2 and 3, which would be a 5. When I plug 2 in here, I get 2 minus 1, or 2 minus 3, which is a negative 1. Down here, I plug in 2 minus 1 is a 1. And down here, I get 2 and a negative 4, which is negative 2. And I think I end up with 5 over 2. And 5 over 2 is going to be approximately 2.5. So that's where I am now. So at 2, I'm going to be approximately 2.5. So somewhere about right there. Since I have a point below the horizontal and above the horizontal asymptote, I'm going to assume that I cross the horizontal asymptote. I will never cross vertical asymptotes, but I can cross horizontals. So I'm going to go up and approach that vertical asymptote, come down, and I'm going to come down and approach this negative, or this the other vertical asymptote, the one at 4. And my graph in the middle should look something like that. Now I need to know what happens on the right side of 4. So I'm going to go ahead and substitute in 5 and 6 just to let you know. To save us a little bit of time, when you substitute in 5, you're going to get 4, and when you substitute in 6, you're going to get 1 and a little bit. So actually, you're going to get 2 and a little bit, point something. So I'm going to go ahead and graph what those would be. So at 5, you'd be way up here at 4, and at 6, you'd be at 2 and something. Should be right here. So our graph again would come down and approach this asymptote, and your graph would look something like that. All right, let's look at graph number 3. Again, we want to factor everything we can at the numerator and the denominator. In this case, really, than the numerator. We would have a difference of squares, so it'd be x plus 4 and x minus 4 all over x. All right, let's take a look now at our x-intercepts. Remember, our x-intercepts is what makes the numerator 0. So in this case, that would be our x values would be at -4 and at +4. Let's go ahead and put those on our graph. We know where those are. So at -4 and +4. All right, so we have 2 points on our graph. Next, we're going to talk about y-intercepts. Y-intercepts is what makes the, when all the x's are 0, and we got a little issue here. If we make the bottom x 0, we're going to have an undefined term. So we have no y-intercept. A while ago, we had no x-intercept. That probably means that the y-axis is going to become an asymptote. So just keep that in mind. All right, the next thing we're going to do is we're going to talk about vertical asymptotes. And again, remember, a vertical asymptote is our domain restriction. And our domain restriction, of course, would be 0. So x cannot equal 0. So our vertical asymptote, of course, is x does equal 0, which stands the reason why we had no x or y-intercept. So our y-axis, x equals 0. Sorry, that's really not good. You know it's really not curvy. I'm just doing that so we can see that it's not the line. All right, so that's our asymptote for right now. All right, let's talk about our horizontal asymptote. Comparing the degree of the numerator to the degree of the denominator. The degree in the numerator is 2, the degree in the denominator is 1. It's bigger at the top. All right, if it's bigger at the top, then we have none. We don't have a horizontal asymptote. And for right now, not always, but most of the time, in at least the problems we're doing now, because it's greater by 1, we're going to have a slant asymptote. And you're going to find that by long division. So I'm going to come over here and I'm going to go x squared minus 16, and I'm going to divide by x. Now, you're going to keep synthetically or long division until you get a remainder, and the remainder won't count. It'll just be what you end up with in the top. So we're going to go x times something is x squared. That would be x. So that's your x squared. We're going to subtract. So our x's cancel. We end up with -16. Now, if we had an x value in here, we would be able to go again and put something else up here. Because there's no x value, then we're just going to have the remainder of -16, which doesn't count. And then our slant asymptote is simply y equals x. But please understand, this could be y equals x plus 3 or x minus 4 or whatever it is up here. So don't think that it's always y equals x. I just don't want you to get that misconception. Okay, I'm going to cross that out since I don't want that to confuse this problem. All right, so our slant asymptote is y equals x. So I'm going to come over here and we're going to put that, our y-intercept, of course, is 0, and our slope is 1, so it's just going to look something like this. I'm going to dash that in, and then I'll kind of squiggle it, so it's also an asymptote. So that's also an asymptote. Again, we're going to have part of our graph on the right and the left. We have a very big hint here. Since we have this point over here, I'm guessing that we're going to go toward the asymptotes. And we have this point over here, I'm guessing we're going to go toward the asymptotes. All right, and there we go. All right, one more graph. All right, this is our last graph. You do need to graph those three, again, that I gave you in the last video. If you don't, you're going to be not a very happy camper. All right, here we go. We're going to factor all we can. Take a 4 out of the top, and you have x minus 2. And in the denominator, we're going to factor out a 3x squared, and would have x minus 2. All right, we're going to have a cancellation, and because we're going to have this cancellation, that means we're going to have a hole in our graph. I'm going to immediately go over here, and I'm going to write the word hole, and I'm going to put a little thing. If there's no cancellation, you have no hole. If you have a cancellation, you do have one. Make sure you're clear on that. The hole in my graph is going to occur where x, in this case, is 2, because that's what would make this 0. So 2 something will be where the hole in my graph is. And we'll figure that out in just a minute. Let's go ahead and look at our reduced version, our simplified version of our equation. We are now just working with 4 over 3x squared. Please remember, after you make the cancellation, then you will use this to graph from here on out. All right, and then we'll just need to make sure we mark our hole in the graph at the end. All right, so let's talk about our x-intercepts. Again, this is very similar to the first graph we did. The x-intercepts is what makes the numerator 0. Well, nothing's going to make that 0, so we have none. No x-intercepts, probably meaning that our x-axis is an asymptote. We'll see in a minute. Y-intercepts. Y-intercepts is when we make all of the x's 0. Well, if we make this 0, it's going to become undefined. We can't have an undefined term, so we have no y-intercepts. Big hint. I'm guessing those are going to both be asymptotes. Let's take a look. Vertical asymptotes. Vertical asymptotes are what make the denominator 0, or it's the same as our domain restriction. Our domain restriction of our denominator would be 0, so x could not equal 0. Therefore, the vertical asymptote is x does equal 0. So there we go. Vertical asymptote is the y-axis, which is x equals 0. I do that really extra squiggly in the same spot every time. All right, so there's our asymptote. And then our horizontal asymptote. We're going to compare the numerator and the denominator again. Degree of 0 up here, degree of 2 down here. So smaller at the top means y equals 0. Y equals 0. Therefore, your range could not be 0. I don't know if we've written that before. Y cannot equal 0. All right, so horizontal is a y equals 0. So that would be our x-axis. All right, so there are our two asymptotes. The next thing we're going to do is go ahead and use a t-table to plot a few points. And then please don't forget about the hole in the graph. To figure out the y value of that hole, we're going to plug in 2 into this graph. So it's like we plug in a 2 right there. And if we did, 2 squared would be 4 times 3 would be 12. 4 over 12 then would just be 1/3. So the hole would be at 2 1/3. And we'll mark that 1/3. We'll mark that in just a minute. Let's go ahead and do our t-table, and again we're going to plug things into this reduced equation. So if we plug in, since we want to go left and right of our vertical asymptote, let's plug in 1. When we plug in 1 for the x, just so you know, we'll get 4/3, which is 1 1/3. So we plug in 1, would be 1 1/3, be right here. We could also plug in 2. When we plug in 2, we're going to end up with 1/3. So at 2, we would end up with 1/3, and I guess our graph is going to approach these asymptotes like this. And on the left side, we would plug in a -1, and when we do, we get positive 4/3. This looks a little different than some we've seen, so that's going to be up here. And when we plug in -2, we're going to get a positive 1/3. All right, so again, right here. So these are both above. We haven't seen a lot of that, but I like it. You could see that again, you never know. And then the hole, remember, is at 2 1/3. So at 2 1/3 is really the hole in our graph. So this point right here really should be a hole, and you just make a big open circle, and I will know that you mean a hole. You can also identify it for me if you would like, and go Bearcats. All right, the last thing I want to just mention to you is I've got one more little extra practice problem, and then just a little bit of advice for your studying. Here's an extra problem. What if we had something like x squared minus 4 over x squared minus x minus 6? I'm going to factor the top, x plus 2, x minus 2. And in the denominator, I'm also going to factor. I would have x and x. I need to multiply to -6, add to -1. I believe that's going to be a -3 and a positive 2. Oh, well, we're going to have a cancellation there. That's one thing that you want to notice. I want to talk about your domain. Your domain restriction here would be at 3. X could not be 3 or negative 2. Just making sure that. But the domain restriction couldn't be at negative 2, only at the whole. So only at the whole, not all of negative 2, because that would actually cancel. So you'd really be dealing with x minus 2 over x minus 3. So be really careful of that. That's kind of a interesting little point here I want to make. Your vertical asymptote would be x equals 3 only, because negative 2 would be where you would have a whole, not an asymptote. Just making that a big, big point for you. And then finally, your horizontal asymptote, comparing degree of the numerator to degree of the denominator, 1 over 1, and that would be y equals 1. Okay, just be really careful if there's any cancellation, that you realize that it's really not an asymptote anymore. You're dealing with this equation, but that you would have a domain restriction at that particular location, x value, only where there is a whole, but not everywhere else. So your domain, you really could write this would be perfectly fine. The last thing I want you to do is I want you to go back and make sure you review the 5 problems assigned on the last video of 2.6 day 2. I'll be in class tomorrow morning before school at 6:45 if you have any last minute questions, and you all have my phone number, so you can call if you have math questions tonight. But hopefully between this video, the review you did in class, and then the opportunity in the morning, that will make you good. Study hard, and let's make this a really good one, and go Bearcats!